Peace be upon you, and welcome to my channel. In this video, you'll learn how to start the GE 9001E gas turbine using the Mark VIe simulation. If you want to know how to install this simulation, please check the previous video on my channel. Check the comments for download links, because many sequences happen almost simultaneously, and I want you to see all the ones that appear on the HMI depending on turbine speed. I repeat some actions or start back from a previous turbine speed. Sometimes I pause at a certain speed to explain. You should know that a lot of preparations are done before starting the machine. I will teach you about the steps related to the HMI. It's important to understand the auxiliary systems of the turbine to better understand the starting sequences. Now, let's start. Set the operating mode to auto. This mode takes the unit from 0 to full speed no load. No load simply means the speed TNH is at its full value while the 52G breaker is open, and the generator is separated from the grid with no load attached to our machine. The permissive signal L14HR turns green. The status box will show ready to start, and the control mode is now auto. Now press the start button. The turbine status changes to starting. The L4Y protection circuit is deactivated. Its displayed background changes from green to red. The cranking motor 88CR starts by closing its 5.5 kilovolt breaker. After 2 seconds, solenoid valve 20TU is energized to fill the torque converter. This valve is very important, and GE didn't think it needed to be drawn or animated on any screen. Motor 88TM sets the torque converter blades to maximum torque. The next action in the start sequence is the starting of pump 88C3 or 4, followed by 88WC F1 through 6. The latter is not configured to function correctly in my simulation, so it will not be the next thing to observe in this video. As the shaft begins to rotate, the speed relay L14HR is supposed to be activated when the speed reaches 1 to 5 RPM. But in our simulation and the real HMI server, it always shows L14HR when the speed is under the L14HM de-excitation set point. If you watch the starting process through the Motors tab of the control section, you will see that 88QA, 88BA1 and 2, and 88BA3, 4, 5 Group A are on. By getting used to this simulation, you will notice that fire damper positions are not shown on the HMI. That's because our simulation still needs a lot of work, and GE doesn't take its job seriously. Anyway, the enclosure ventilation fans are not needed until we are close to the firing moment. When we give the start order by clicking Start, the cranking motor 88CR and rotor bearing lift pumps 88QH1A and 88QH2A start. We need the lifting pumps because the generator rotor is very heavy and requires additional pumping power at low rotor speed to create an oil film that prevents friction. If the auxiliary oil pump 88QA wasn't already working, it would start with them. On the Lube Oil tab of the auxiliary section, you can see the oil pumps, pressure switches, pressure transmitter for generator bearing lubrication, oil filter OK status, control oil pressure, hydraulic oil pressure, tank oil temperature. The unit can't be started if it's under 24 degrees Celsius, and the temperature of the oil drained from the bearings. The oil that goes to the cranking motor is drained using solenoid valve 20TU. That's the same one that closes to fill the torque converter. On the generator cooling tab, you can see the operation of 88WC3 or 4. These two pumps circulate the generator cooling water. They start first, followed by 88WCF1 through 6. These motors are fans used to refrigerate the cooling water. They start early, even though they're not needed until excitation and power generation. 88WC1 and 88WC2 are used to refrigerate the turbine legs. In the oil cooling tab, you can see the prioritized water pump in use, the working pump, the state of the water pressure switch, the oil cooling fans 88OCF1, 2, and 3, the cooled oil pumped by 88QA, and the water pumped by 88WC1 and 2, exchanging heat with forced cooling air from 88OCFs. The oil cooling fans are supposed to start after 88BA1 and 2, and before the opening of the fire dampers and the starting of 88BA3, 4, and 5. Anyway, the temperature control valve VTR1 doesn't let oil pass through the fans until it reaches a certain temperature, and that's the correct time for the cooling fans to start. VTR3 opens to compensate for water loss in the system. In the control oil tab, you can see that the control oil pressure and the excitation of solenoid valve 20FG happen at the same time the auxiliary high-pressure oil pump 88HQ starts, which is also when 88CR starts. And as always, I still don't understand why the system starts 88HQ and energizes solenoid 20FG to send high-pressure oil to the GCV and SRV, even though they are not needed until the firing phase. On the FSR control tab, you can see that fuel stroke reference is controlled by the startup control loop, and this loop keeps controlling the FSR until we reach full speed no load, FSNL, in auto mode. If the exhaust temperature or acceleration exceeds a certain set point, their respective loops will take control of the FSR from the startup loop to ensure the safety of the unit. The startup control operates as an open loop using preset levels of the fuel command signal FSR. The levels are 0, fire, warm up, accelerate, and max. The software sets maximum and minimum FSR and allows for manual control. Clicking on the targets for Man FSR control and FSR gag raise or lower allows manual adjustment between FSR min and FSR max. As for the IGVs, they require both control oil and high pressure oil to be present, and solenoid valve 20TV must be energized to let control oil into the system. They don't change position until we reach about 80% of nominal speed. A lot of details are displayed on the IGV control tab. I might explain them in a future video if you like my content. It requires understanding of temperature, IGV, and speed control loops. Until now, FSR, fuel stroke reference, remains at 0%. Anyway, at the moment the purge timer starts, motor 88TM sets the torque converter blades to purge position, and speed level relay L14HM is energized. At this moment, the L14HM permissive background becomes red. The turbine speed relay L14HM indicates that the turbine is turning at the speed required for proper purging and ignition in the combustors. Gas-fired units that have exhaust configurations which can trap gas leakage, like boilers, have a purge timer L2TV, which is initiated by the L14HM signal. The purge time is set to allow 3 to 4 air exchanges through the unit to ensure that any combustible mixture has been purged. The starting means will hold speed until L2TV completes its cycle. Units without complex exhaust systems may not have a purge timer and rely on the starting cycle and natural draft for purging. When we reach about 16% of nominal turbine speed, generator bearing lift pumps 88QG1 and 88QG2 Group A stop. They're not needed above this speed. When we reach about 19% of nominal speed, solenoid valve 20TV is energized and control oil flows to the IGV position control system. The startup status changes to cranking, and as you can see, the purge timer is still counting. The L14HM signal, or the completion of the purge cycle, L2TVX, enables fuel flow, ignition, sets the firing level FSR, and initiates the firing timer L2F. This timer lasts 1 minute. If no flame is detected by the end, the turbine will automatically trip. The ignition timer is not displayed on the HMI. Apparently GE didn't think it needed to be visible. I'll show you how to add any existing but non-displayed point to the HMI screen if you're interested. Just let me know in the comments. I hope this video helped you understand the first steps of starting a GE 9001E gas turbine using the Mark VIe system. If you found this useful, like, share, subscribe. Thanks for watching, and see you in the next video.